Welcome to DDN's presentation of AI for Enterprise, what leaders need to know now. In just a few minutes, you'll hear from DDN's own industry leaders as they break down where AI is making the biggest impact and how today's enterprises can take action. We are excited to share these insights with you. Let's dive in.
A few years ago, we had the unfortunate situation of the pandemic. Okay, what did that do in technology and enterprises? It forced companies to innovate faster, right? Digitally transform faster so they could keep their businesses going because everybody was remote, everybody was working from home. A lot of technologies had to be accelerated in order to still be productive, okay? Now, what we're noticing with AI is that is again getting supercharged further 10x going forward, but enterprises are still in early days. So if I'm an enterprise, I'm a CXO or a VP of IT of an enterprise, why should I be considering AI and why do I have to do it right now, right away?
Because if you don't do it, you're going to go out of business. The reason for that is quite simple. AI is essentially a massive improvement of productivity of your workforce. So if you're not leveraging AI, your workforce is going to be behind the competition and you're not going to be able to keep up with the pace, how fast your competitor is going to innovate and bring new products to market and further excite customers by an AI-enabled tools that the customer interacts with your company.
Companies that don't adopt AI are going to just be left behind. 2.5 years ago, in particular for language models. But if we think about computer vision models, they are driving our cars today in many cases. They are helping us. Computer vision was there. And today we cannot think of a world where computer vision is not applicable, cannot be applied. Now the range of cases and use cases and customer use cases in general has expanded with ChatGPT first. And the evolution just is growing, it's faster, it's exponential, and will continue. So the sooner companies start their AI journey, the better, because otherwise they're going to be too behind.
So ChatGPT, the product owned by OpenAI, it's a heavy undertaking. That's billions of dollars. I'm an enterprise. I don't have those kind of resources. Well, what do I do?
Well, there are many alternatives, high-quality alternatives that today are open source and they are free. Now, what that entails to bring a model that is free of charge, zero cost to train. How do we deploy and make it work for a customer? So this is where platforms, a data platform like DDN Infinia comes into place. Having the ability to change the weights or upload these models in real time and serve a customer is paramount to make this effective. And of course, there are other complementary tools like NVIDIA NIMs or cloud providers that can give more of the execution part and help with execution. But we are building the whole platform to enhance and facilitate or simplify the customer journey, the customer AI journey as we move forward.
And I think another aspect of that, which is very critical, is not everybody needs to be an OpenAI. Because as Omar just said, OpenAI is one implementation or one execution of a large language model that is trained and available. You can license that if you want. There are other enterprise-ready large language model available for licensing on top of open source models that are actually very capable. Given that there is a lot of competition in this space amongst very large companies, that will drive the cost of large language models down. That doesn't mean the development of the large language model is going to come down significantly, but be able to leverage one as an enterprise will come down, which means enterprises don't need two large companies that build large language models, but they will leverage one of them and then invest in their own infrastructure that is more focused on tuning an existing model in order to participate, for example, in an end-to-end RAG pipeline where they provide value to the customers without investing into a large language model itself.
So that's a great segue into what I wanted to ask you guys next, which is, let's make this real. Explain in industry terms what you guys just talked about. Financial services companies have to deal with everything from rapid ingestion of data for their trading platforms to really incredibly powerful fraud detection, because that happens a lot for them. Now, how do you apply what you both just talked about? It doesn't have to be an OpenAI type Herculean effort, but enterprises can take easily accessible open source model and proprietary models that and products like we provide at DDN, like Data Intelligence Platform and Infinia, and how do they combine these things along with NVIDIA's ecosystem maybe and drive these outcomes?
It's not like fraud detection is not possible to do today. The problem with fraud detection today is it takes too long to actually get to the actual, detection part. And so what companies are striving is to get this to absolute real time. And so in order to do this, you need to very significantly accelerate the execution on the fraud detection part. So in the earlier years, this was done with technologies like Hadoop, where people through batch processing basically go through large amounts of data, try to identify things. But it's a process that, lagged behind hours or days and, with lots of efforts, maybe, minutes. And so in order to get this to this level that I mentioned, where in real time these things can happen, you need a much more sophisticated amount of infrastructure. The software capabilities you need to enable these kind of things are not just driven by data like documents or transaction numbers. You need to have a way to actually integrate metadata into this data in order to properly rank risks and rank amount of incidents that happen around the same topic. And the way people do this today is they use more traditional storage systems to store data. They use transactional databases to store metadata in it. But it's essentially a large number of completely independent and discrete pieces of infrastructure. The key value DD and Infinia brings to the table here is that you get a single data management platform that can provide the possibility to store the data, but combine it together with the metadata and make it an actionable thing for the application.
Okay.
And that allows it to integrate with the higher level analytic tools, leveraging standardized interfaces or highly differentiated accelerated interfaces if the customer choose so, to basically get to the result.
And actually using the metadata, the same data can be sent to train a model and or refine an existing model.
Correct.
Okay.
So everything in only one platform without having to move from platform to platform, data store to data store. Only one place that can solve all these problems. Similarly with the high frequency trading, just imagine besides a tick or one particular company performance, there are news that have to be analyzed in real time. News coming from many different sources in many different ways. Social media.
Yes.
Videos.
Tickers.
Everything.
Sources.
That usually they get processed by another set of machine learning models, AI models, that are going to be extracting interesting information and storing as part of metadata that then can be cataloged and used to retrain some models that are doing the trading.
Okay. So to wrap up the financial services piece, what I'm hearing is a lot of these things enterprises have been trying, right, for a few years now. But what AI is going to do as step one is accelerate it by a 10x, 20x order of magnitude, make it extremely precise, whether it's fraud detection, trading, others, your precision is going to be supercharged. And last but definitely not the least, since it's financial services or any industry, they're going to save a lot of money, not for them, just for themselves, but for their customers, because frauds and scams won't happen as often. Trades will happen in the way they should happen, right? People don't miss their opportunities. But is there, the one last question I want to ask on this before we move on to the next industry is the common person now as powerful as a large trading company in terms of their ability their access to information, their access to be able to trade at the same level as a large trading company? You know what I mean? But today with AI, is it also trickling down to the common person?
It is. But also AI is converting us on writers, or we are creators of videos today with the new tools that are coming up to market. This is what AI is doing, or enhancing us to produce the first result. Of course, there are always going to be experts. There are only going to be a 5-10% of the population that is completely different from the rest. But AI is enabling us to do things that we couldn't do before.
Let's move to healthcare as another vertical I want to talk about, because again, it impacts everybody. How, if I'm a healthcare company or I'm a company that's into like drug discovery and things like that, how do I look at AI what is the starting point for me, and how does the technology that DDN, brings to bear, our DDN data intelligence platform, how is that going to apply to some of those use cases?
I think one of the biggest drivers of that is going to be something real, like highly personalized options for your health, no matter if this for treating a particular, deficiency or treating a particular illness that you have, being able to personalize that. Because at the end of the day, most of that is something that we will be able to, in the foreseeable future, to basically use a more generic model that has been developed and then significantly personalize it to an individual. And so AI obviously is going to be one enabler for that. But more so also on the technology side, you need to have the right technology in order to enable AI to do that, which means, again, you need to be able to store generic data, personalized data in a very secure way, and then apply different weights to the individual to fine-tune the model to get to the exact precise prescription or whatever, like a dose of a medication that is needed to a particular person based on its DNA, its weight, its height, its body composition, and so on and so on. And AI will clearly supercharge and enable this in that industry.
Yeah, or even by race, for example.
Yeah,
right?
There are race-specific, illnesses that only exist because of a particular DNA strain that only exists in particular races. Absolutely. Yeah.
Yes, the whole history, personalization. Personalization applies to other industries, but in particular in healthcare, having the technology that can give one model per person, one very large model per person, would be ideal. If we also add to that model what is called RAG, but essentially augment that model with a knowledge base about the last time that the person visited the doctor or any other symptoms that the person may have, or anything that is happening in that area, for example. For example, everybody in that region has gotten COVID all of a sudden. This is actually extremely powerful for a diagnosis. In the particular, the nephenia with this extremely fast, low latency S3 is enabling that part, in particular serving many different versions of the model, fine-tuned for each individual. This is key to provide a real high quality of service to a customer.
Okay, so what I'm hearing is, again, correct me if I'm wrong, most of these patients will use a generic trained model, right? And then they will fine-tune it based on their specific, requirements based on whatever, health history, race, other, and the prescriptions will change accordingly, and that model can live with that individual through their lifetime.
But it's not just that. You can also think about this, even going further fine-grained, you can have a more generic model that you then train, for example, cancer detection. And so you train this very specifically on cancer data. So you make a model that is highly optimized for that. And then within the model, you can even further fine-tune it on very specific individual pieces that I mentioned before. So think about this more like a hierarchy of models. It's not just there's this one model. There's this one model that is the starting point. From there, you highly optimize it for a particular use case, and then you personalize it on top of that. And you can think about this, on cancer treatment. This could be, diets. It could be, what are things that are particularly good for your body composition to eat that your body can better digest, or, embeds less fat in your body, or whatever it is. There's all kind of different use cases you can think of, which at the end of the day all initiate from a large model that gets more specialized into a particular area and then personalized to an individual person based on their attributes.
Let's just bring this industry conversation and tie it back to the technology piece for a second, okay? Because I feel like the data intelligence platform from DDN has several benefits that are cross-industry, right? For example, data ingestion, of various data types, that's across industries. That's not specific to any industry. So can we walk through, for an enterprise I'm just gonna make myself into an enterprise healthcare company for a second, right? I'm CXO of this company, and I'm trying to get some quick wins in AI for my company. And that could be, to your point, could be something related to personalized prescriptions. It could be nutritional dietary stuff, or it could be something more complex as cancer research or genomics research. I have an existing ecosystem. My IT infrastructure is already complex, right? I've bought storage systems from a bunch of traditional storage vendors. I've got networking stuff. I've got multiple clouds. I've obviously got a multitude of data types from coming in from all over the place. Now, how do I even get started on some of these cool things you guys are talking about?
I will start with just one small use case, personalization, because we've been talking about personalization. Let's say the customer is using one cloud provider like AWS. AWS support this kind of personalization, and the backend actually they're using S3. We offer with Infinia and two orders of magnitude lower latency S3 version, object storage. It's just as simple as deploying Infinia on AWS and pointing, instead of their S3 bucket, pointing to an Infinia bucket. What it means is the model gonna be ready to serve. The customer will have a faster response and actually a more integrated, a smoother response and experience from the customer side.
And one of the nice things with Infinia is it's something you can start very small and you can grow. So you don't need to be a hyperscaler to use that technology, but you can start with a very small footprint, kind of a POC, and then you can just grow to whatever size you want. One of the differences with other technologies is typically you need to upfront know what is the size of your deployment. So there's a huge upfront cost to get started. With Infinia, you can start at a smaller scale and then just grow it as you need it, because it's built on web scale technology similar to Facebook and other technologies, where if there is more load coming in, the system simply can grow to whatever size you need it to be.
Okay, so what I'm hearing is it augments whatever already exists. Again, I'm still the CX of this healthcare company. So in my infrastructure, whatever I already have, DDN, Infinia, and the data intelligence platform will augment everything that I already have.
Exactly.
We'll be able to ingest data from whatever sources I throw at it, right? And process it at a much faster rate, to your point, in comparison to traditional S3 infrastructures like AWS provides. And start seeing real business outcomes in the applications that my application team is building at a much faster rate. Now, I want to take this a little bit further down. Okay, now I'm no longer the CXO. Okay, I'm someone who actually has to go implement this stuff, right? My CXO has told me that this is important. I've heard about DDN and this cool technology that these guys have, but I'm already using Databricks, Snowflake for analytics. I'm using sales and marketing automation tools. I've got a plethora of tools already. Why should I add one more thing?
So because it significantly accelerates some of the things you already have. So for example, if you have a Databricks implementation, Databricks needs to store and use its analytics engine against data somewhere. And so the typical choice is usually you run this against an S3 object store. So if you run this on AWS, it runs against the AWS S3 object store. So Infinia is basically a one-to-one replacement for that. So you can deploy this in AWS, you can deploy this also on GCP, and you can deploy this on-prem. The benefit is it is essentially a 100% compatible replacement of AWS S3. So the question still remains, why would you do it? Well, in order to get very fast insight and have a very good customer experience, the time to actually return results is key. Think about you in front of some chatbot and you're talking to it and it takes a minute to return your answer. You're obviously not going to be satisfied by that. What you want is a real-time response from the system. So Infinia is 2 orders of magnitudes faster in time to first byte, which is the thing that is critical to augment responses that are going back to a user compared to traditional AWS S3. AWS S3 also has an express version. It's a version that is, multiple factors more expensive than standard S3, but even that is still an order of magnitude slower than Infinia, which is more cost comparable, to an S3 implementation. So we can deliver you a much better end user experience with your existing tools, even with simply replacing AWS S3 with Infinia's S3 implementation. And that is something that doesn't require a lot of skills, because Infinia has purpose-built to be super easy to install, super easy to manage. So you get a cloud-like experience from the software product of DD and Infinia that immediately accelerates whatever you're doing today. So you don't have to replace, your Databricks implementation. You don't have to replace whatever other technologies use. You simply replace the backend data infrastructure for Databricks.
So I like that. So you've attacked that problem from an infrastructure upwards motion. Omar, I'm going to go application data downwards with you on the same problem, right? So again, I'm in the IT team of this enterprise, and I'm an applications engineer, or I'm at a very high level in the stack, right?
Yes.
So how am I interacting with DDN's data intelligence platform and Infinia? And what do I stand to gain by speaking to my infrastructure person, about this, or directly to DDN about this to say, how can my life be better?
Well, in that case, the first thing you have to do when you use Databricks, for example, is convert everything to one common format. Okay. That means all the data in the company is constantly converted into one common format. As an IT person, that IT person has to connect all the data sources, send it to one place that then gonna be converted to a different format. There is risk of losing data. There is risk of course, there is time involved, there is compute involved on doing those conversions. This is where Infinia plays a big role, because we're going to take care of those conversions. We don't need to do those conversions. We essentially map our internal representation of the data into the way it's going to be used. This is an immediate gain in addition to the performance side that a customer will have, or user will have. Just the simplicity of having to, they can use exactly the data the way they ingest it.
Okay, I'm going to take this conversation a little bit towards the GPU side of things. Because again, as an enterprise, I don't have access to GPUs. So what are my options? I mean, am I even going to be successful with AI? Should I even get started since I don't have any access to GPUs? Why am I even talking to DDN?
I mean, the nice thing is, as we mentioned before, the DDN Infinia product is a software product. So you can deploy this on-prem as you can deploy this in the cloud. So what a very good starting point is, you do start in the cloud, because in the cloud, GPUs are freely available. And so you can start there and you can, deploy this at whatever scale you want. And eventually you can bring it on-prem, because one of the other benefits of Infinia is, given that it's a software technology, it's freely available everywhere to be deployed. The benefit of using something like Infinia is that the same interfaces, the same APIs, the same application integration is going to be available on the cloud as well as on-prem. So you can deploy it at whatever location choice you want.
Yes, and pricing is very different from cloud to cloud provider to cloud provider. CPU costs, the price is very different.
Okay.
That with Infinia, the enterprise can avoid vendor lock-in. They can just move the infrastructure to where they need.
Very good point. Yeah.
Data mobility is a key aspect for customers. How can I develop an application that I can run on-prem, later in the cloud, or move it back? Because that's the only way I have full cost control. If I can move the execution of the application to whatever infrastructure I want.
So it's basically the elasticity of pricing, as well as maybe the data services that a specific cloud provider will provide tomorrow is better than what I have today.
Right.
And I want to move. Infinia just makes it easy.
Correct.
Whether it's a price or a function or a feature, that's the reason that drives me to another cloud. Now, one thing we didn't talk about, in this whole conversation is the edge, right? There are a lot of industries that service the edge, right? They have sensors in the edge, they have devices in the edge, and AI relies on data to and from those edge devices to be successful.
Right.
So talk to me about some of those edge use cases that you guys can think of, and how the DDN Data Intelligence Platform applies for the edge use case.
So one of the nice things with Infinia is it's a pure software product. And it was designed from the very beginning to operate in very, very small footprints. So the Infinia software can run on anything from, like an NVIDIA DPU, like a Bluefield adapter, but it can also run on a very small ARM system. So if you have like a telco rack sitting somewhere, all you need is a little bit of compute resources on it, and you can run the entire Infinia stack on it. So that, because it is not tied to any particular hardware, it allows very easy integration into an instrument, into sensory instruments. It can be run inside a camera. You could technically run it inside a car. So it's really designed to run at a very, very small footprint. And then you can leverage some of it advanced data management functions that we're working on to, for example, only transfer information that is actually interesting in the core from the edge into it. So you can do pre-filtering and things like that on the edge, because sometimes there is not enough bandwidth to transfer all the data, but only the data you actually really care into the core data center or into the cloud.
Yes, it happened with industrial AI. This is one really good use case where, for example, there are many sensors, IoT sensors, and most of the information arriving to a central CPU or central compute can be safely discarded. It's only the data of interest that should be transferred to another place for processing. Again, given that Infinia can be deployed anywhere, is actually a great tool to support these use cases.
So deploying Infinia is one aspect of it. Why are we even considering it in the first place on the edge? What is the use case?
It's different things, but one of the biggest problem with IoT devices is that the amount of data that you produce is just immense. And you cannot take every data and process it, as Omar just said. There's too much information that are duplicates or information that are not necessarily important to increase the precision of the outcome, for example. So an end-to-end workflow would include something like you're going to set a filter on the edge for informations you really care about, like a particular event or above a certain threshold of a particular sensor. And only if any of these events hits, then you want to take the data and move it somewhere. So this requires very sophisticated features inside the DD Infinia software that allows you to set up queues where you can say, hey, if information meets a very specific requirement, I want to track this so that at a later point in time, I can very efficiently move it into the core or move it into a cloud instance, for example. And these are kind of capabilities DD Infinia enables you to do.
And the same features we offer for the data center or the cloud, they apply to the edge, right? And even though it's a smaller footprint, of course, the performance won't be exactly the same. But all the features on security, data, metadata management, everything applies. And again, goes back to the portability. One data scientist used to one particular platform, they can move and apply exactly the same mechanisms, no matter where it's deployed.
And another thing that I think is very useful to mention is requirements change of what data you actually care about. And so obviously these triggers and filters can all be updated in real time. So imagine you say, hey, I'm building an autonomous car and I need to improve stop sign detection. You can go out and go in all these distributed, regional connection points of data that is uploaded by the cars and can say, for the next hour, I need to collect every stop sign you come across. Only those stop signs going to get forward, but others not. And this is really a simple way of defining a filter to only filter out stop signs and ignore everything else. And so being able to update this in real time is a very critical component because requirements going to change. And so doing this filtering on the edge is significantly more cheaper than transferring everything into the core to then discard the data.
Okay. So it's a real-time event-driven architecture that supports everything that happens on the edge by informing the core or the cloud wherever the information is coming back. Makes it way more efficient, way more productive, and only sends the data or receives the data that is required. That's how the efficiency really goes up.
Correct.
Okay, fantastic. Again, we're focusing on the enterprise for this conversation. And if I'm an enterprise customer and I'm taking these baby steps, as I like to call it, towards implementing AI for my various workflows, whether it's sales, and marketing automation or improving my supply chain or other, how do I approach it? All the way from, I mean, you guys seem to have deployed AI at scale, right? And at various enterprises. So you seem to have seen the whole gamut of AI implementation. But I'm an enterprise who's trying to get started with my existing ecosystem that is already pretty much a data sprawl. How do I think about DDN? How do I think about AI? How do I think about the NVIDIA ecosystem and get started with my pilot program?
Yeah, I would take a very, specific use case that you believe your workforce is, spending a significant amount of time. Figure out what is the data required to improve that, and start, a small system. Go to one of the GPU cloud providers or a hyperscaler. Get some GPU infrastructure in place that you rent. Get an Infinia system up and running. Start operating at very small scale. Start leveraging the existing analytics frameworks. Some of them are freely available as open source or tools provided by the cloud providers, and get started with a very specific use case.
Yes, an approach to us, to DDN. We offer POCs, we offer blueprints. We can help on that journey. Just talk to us. We're going to help specialists helping with the first use cases. They think that they're the more appropriate.
Okay. So their job on their end of this taking the baby step approach is to identify use cases that they feel are quick wins in AI, where they don't have to invest heavily upfront. Once they've identified those use cases, identify the key parts of the IT infrastructure that are impacted by that use case, and then talk to DDN and NVIDIA to see how we can apply our frameworks and our platforms into their existing IT sprawl, right? And drive outcomes for those pilot projects or first use cases. Is that what I'm hearing? Did I summarize? Is that okay? Yeah. Wonderful. All right. I feel like I learned a lot today. Thank you. Then we'll do this more often.
Thank you.
Thank you.